We're going to be learning how to do something called common factoring today. So we're going to start off with a warm-up. This is an old way actually from grade school. So what we're going to do, we're going to have a couple of warm-ups here. So the first one is going to be find the greatest common factor. So for example, if I want to find the greatest common factor of 10 and 15. The greatest common factor is the biggest number that goes nicely into both 10 and 15. So 1, for example, goes nicely into 10 and 15. Because 10 divided by 1 is a nice number, 15 divided by 1 is a nice number. But 1 is not the greatest common factor, it's a common factor. 2, 10 divided by 2 is pretty, it's 5. But 15 divided by 2 is not pretty. So 2 is not a common factor. 3 goes into 15 but does not go into 10. 4 doesn't go into either of them actually, because 10 divided by 4 is 2.5 and 15 divided by 4 is 3.75. Either way, not pretty. 5, on the other hand, goes into both of these. So the greatest common factor of 10 and 15 is actually 5. And you either know that or there is a way to figure it out. I mean, I think probably the best way is to just guess numbers and just keep on going until it doesn't work anymore. But technically what you could always do is you could figure out what multiplies to give us 10. So 5 and 2, 5 and 3, and then you look for something that's common. Now sometimes you could have multiple things that are common. So let's say, for example, we had, I wanted the greatest common factor of 24 and 18. So I could just guess numbers, keep on dividing and see what number goes into both of these. Or if I wanted to use kind of the factor tree method, and you could divide up into anything that, it doesn't actually matter what you do. So I'm going to do 18 is 2 times 9, and 9 is 3 times 3. 24 is 2 times 12, and 12 is 3 times 4, and 4 is 2 times 2. So that's called breaking things down into prime factors. And I look for ones that are common. So a 2 is common with a 2, and a 3 is common with a 3. And here we have 2 2's left, and a 3. Those are not common. So what's common is a 2 and a 3. Then we can multiply those, and 2 times 3 is 6. So the greatest common factor of 24, oops, I cut that off. The greatest common factor of 24 and 18 is 6. Because I cut it off, the 2 and the 12, that broke up into 3 and 4, broke up into 2 and 2, 2, 9, 3, 3. And that was that. So the greatest common factor is 6. Now we could do a bunch of these. So let's say we had 4 and 12. You could either do it by that, or we could see that the greatest common factor here is, so here the greatest common factor was 6. Here, 4 goes into 4, 4 goes into 12, so 4 is the greatest common factor. And sometimes it's not even really a pretty common factor. For example, if you had 7 and 11, these are both what we sometimes call prime numbers. The only thing that goes nicely into both 7 and 11 is 1. So 1 is the greatest common factor of 7 and 11. Sometimes you may have to find the common factor of 3 things. So for example, the greatest common factor of 10, if I ask for the greatest common factor of 10, 18, and 20, I want something that goes into all 3 of them. So 10, as an example, goes nicely into 10, and it goes nicely into 20, but it does not go into 18, right? The biggest number that goes into all 3 of these would actually be, so the greatest common factor here is 2. That is the greatest common factor over here. Now I'm going to quickly, I know it's part of the warm-up, but this is not really part of the warm-up anymore. You might have something like this, x to the 3 and x to the 7. And I might say, what's the biggest common factor of these guys? And if we kind of did the factor tree approach, x cubed is x times x times x, and x to the 7 is x times x times x times x times x times x, 1, 2, 3, 4, 5, 6, 7. And what's common 3 of the x's are common, so it turns out an x times x times x is x cubed. So the greatest common factor of x cubed and x to the 7 is x cubed. And if we did it, as I said, what's the greatest common factor of x to the 8 and x to the 22? The greatest common factor would be, there's 8x's here, there's 8x's here. The greatest common factor would be x to the 8. And if I had x to the 11 and x squared, the greatest common factor, there's 2 of them here and 11 of them there, the greatest common factor would be x squared. So that's greatest common factor. Now what we're going to be doing today, we'll do another warm-up actually first. So warm-up number 2. So I want you to expand. We're going to expand these things over here. So 3 times 4x minus 2. When we have a number in front of the bracket, what we do is we multiply everything in front by everything in the bracket. 3 times 4 is 12x. 3 times negative 2 is negative 6. And that's the factored form. Going from there to there is called expanding. So it turns out what we're going to be doing today is going backwards. So from there to there, it's called expanding. And then going backwards, which we haven't learned yet, but you're going to learn, is called factoring. So going from getting rid of the bracket is expanding, creating the bracket is something that we're going to call factoring. You haven't learned factoring yet. We're just doing expanding, which is something you've already learned how to do. 4x times 3x plus 7, and I want you to expand it. So what we're going to do is we're going to, again, multiply into the bracket. 4x times 3x is 12x squared, because 4 times 3 is 12, and x times x is x squared. And then 4 times 7 is 28x. And that's the expanded form of this. And the last of my warm-ups is going to be 8x to the 5 times 3x to the 4 plus 4. This is a slightly more complicated expanding. 8 times 3 is 24. X to the 5 times x to the 4, when you multiply these things, you get just 5x's and 4x's. It becomes x to the 9. And then we're going to do the same thing here. We're going to multiply by the other term in the bracket. 8 times 4 is 32, x5 and no other x's. So it's going to be x to the 5. So that's the factored form. That's the expanded form. We expand going there. We factor going back to there. That's the end of the warm-up. So now we're going to do the actual factoring, common factoring. Examples of common factoring. So the goal of common factoring is going to be to essentially create a bracket. We're going to take something that's common out of both. So we have two numbers here, and then the question is, what is common? So what's common between the 10 and the 15? And that was actually the first one we did. Do I still have it? There we go. So 10 and 15, and we found out that the greatest common factor was 5. So what I'm going to do is this is kind of a procedure. I'm going to put an equal sign in the front of the line because it's not an equation, it's an expression and we're just changing what it looks like. We're going to find the greatest common factor and we're going to put it in the front. Then we're going to take each term and we're going to divide by that number, by that greatest common factor, by the thing that we put in front. So we write the greatest common factor in front, open a bracket, divide each term by that. And then we get 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. And what we have here, this is our, so when from there to there, this is factoring. So when we went from there to there, we factored, and we common factored. So common factored means that we found something that was in common between the two terms, and we factored it out. That's the term that we use for that. It was factored out. And it's not always possible to factor things out. I mean, if you have, for example, 7x plus 11, the only thing in common here would be, there's nothing in common with 7 and 11, so the common factor would be a 1, and that'd be 7x divided by 1, divided by 1, which is 1 times, and 7 divided by 1 is 7x, and 11 divided by 1 is 11, and that gives us 7x plus 11, which is exactly where we started, so that was kind of boring. We really didn't common factor out anything of any use. So usually we are able to factor something out that's useful. I'll do one more quick example. If I had 12x plus 28, so a common factor here is, so both 2 and 4 are common factors. Let's say we did the best one first. Let's say we said that the common factor was 4. So we pull out a 4. And we divide each term by the thing that we've pulled out. And so we get 4 times 12 divided by 4 is 3, and 28 divided by 4 is 7. So that would be pulling out the greatest common factor. Now, let's say we're going to do the exact same one. So I'm going to do C again, 12x plus 28. But let's say instead of pulling out the greatest common factor, I just pulled out something that was a common factor. So another common factor of 12 and 28 would be 2. So I pull out the 2 and divide each thing by 2. And we're going to get 2 times 12 divided by 2 is 6x, 28 divided by 2 is 14. And we got a different answer. But it turns out that what you want to do is you always want to factor out as much as possible. So here, 3 and 7, the only thing that they have in common is a 1. And when in math we say that's a trivial answer. Factoring out a 1 is not exciting. That's what we found out on the last sheet, right? When we factor out a 1, that doesn't really do anything useful. So factoring, here we're fully factored. This is fully factored. This is not fully factored, and the reason it's not fully factored is because there's still something in common with the 6 and the 14. So what we're going to do, we still have the 2 in front from before, and we're going to say, what's in common with a 6 and a 14? Oh, another 2. Another 2 is in common. So then what I do is I take the things I have here, and I'm going to divide by 2 again. And I'm going to get 2 times 2. 6 divided by 2 is 3x. 14 divided by 2 is 7. And we're almost done. We're going to take all the factors that we've pulled out, and we're going to multiply them by each other. And 2 times 2 is 4. And we end up with 4 times 3x plus 7, which is the same answer we had up here. So we could either pull out the greatest common factor right away and get right to the answer, or we could pull out a common factor that's not necessarily the greatest, and we might have to do some extra steps, but eventually we'll get to the exact same answer. So in the next video, we'll do some more challenging examples.